Okay, I think I'm live. Can someone confirm if I'm live? Okay, cool. I think I am live. Just a second. Just give me a second. I'm just doing a few things. Yes, okay. We have some people watching. Okay, cool. Perfect. Okay, so as look written in the title, we are gonna be solving Google Kickstart round C. Okay, okay, cool. We are actually going to be solving problem 1 and 2 since those are easy and are almost solved by everybody. Okay, okay, cool. But before that, let me tell you a little bit about myself. Okay, so I am a software developer at Adobe. I don't think, okay, I don't think that slide is here anymore. Okay, just a little bit about me. I am a software developer at Adobe. Before this, I was working in D-Show, okay, as a member technical. I am a candidate master on Code Forces and a 5-star on CodeChef. Okay, then coming on to batches, so Unacademy has different types of batches. The right now there are 4 batches which have already been started. There is a interview batch which has started on 17th May. Then there is a samurai batch which is an 11th month course and it started on 11th May. And then we have Android and Gladiator. So these are a couple of things regarding those batches. You can just like pause the video if you want to see them. This is the complete structure of how the programs are. Okay. Okay, then coming on to, yeah, this is the structure only. These are some of the educators. Okay, then this is the subscription plan. So if you buy a subscription, you will get access to every course for 1 year. Okay, so basically, if you take a 1 year subscription, then you get access to every what do we say course. Okay, as always, there is a referral code. You can use my referral code, which is NBYT. I hope everyone can see on the board. And using this code, you'll get 10% off. Okay, all right. Then without further ado, let's get into solving the problems. Okay, so let me just open up the problems. Okay, okay, so let's look at the very first problem. Okay, so the very first problem is we are given an integer k and a string s of length n consisting of lowercase letters from the first k letters of the English alphabet. Find the number of palindrome strings of length n which are lexicographically smaller than s and consist of lowercase letters from the first k letters of the English alphabet. So basically, what they're giving us is that we are given a complete string, and every character in this is actually like k characters only. In all, there are only k characters allowed, which are from A to like the kth only. Okay. So basically, if k is 3, then that means only A, B, and C are allowed. Okay. And likewise. Okay. Now, what they want is we are given the string. We need to find the number of total strings that are possible of the same. So basically, this has a length of n of the same length. Okay. And that string is a palindrome. So if we look at the example, let's look at an example. So basically, if we are given B and C, so basically length is 2 here and K is 3. Okay. Now, if you see, there are two possible answers. One is AA and one is BB. AA is a string of length 2 and every character in this string is either A or B or C. Okay. So this is one case and the other case is BB. So basically BB is also a string of length 2 and every character in this is either A, B or C. Okay. Let's look at something better. Let's look at a bigger test case now. Okay. So let's look at A, B, C, D and D. Now if you see, length here is 5 and K here is 4. Okay. Let me just quickly write the answers of this also. So basically we have AAA, we have AAB, AA, we have AAC, AA, we have AAD, AA, AAE. Okay, there are many answers. So let's write AB, ABA, and we have ABBA, and we have, yeah, okay, we have ABCBA. Okay, these are the 8 answers possible. Okay, now let's see how to find these values. Okay, so basically, if you look at the, okay, the very first thing that we know is, if we actually fix our very first character, that means we'll be fixing the last character as well, since this is a palindrome. Okay, so what I want you to do is, let's look at another test case for now. Let's say the test case was CD, what, CDB. Okay, let's say that the test case was this only. Now we know that if we take any value as A in the very first character, then every string which is a palindrome will be an answer. So basically we know that if this is A, then the last character will also be A, and let's say K is 4. Then we can place here either A or B or C or D, and these 4 will be added to our answers. Okay, but this is when I had my first character as A. What if I put my first character as B? If I put my first character as B, then my third character will also be B. And now, at my middle position, I can place anything out of A, B, C or D. Reason is because I know this string is lexicographically smaller than this string, because the very first character is B, which is smaller than C. Okay, so that is how I can use B also. So basically there are 4 answers using A, 4 answers using B. Now let's say that we fix our first character as C, because we have already used A, we have already used B, the next character is C. Okay, and we know that we cannot use G as the first character, because if we use G as the first character, then this string will become larger than this string. Okay, so let's skip D and let's say that this character is C. If the first character is C, that means a third character is also going to be C. Now we are only left with the middle character. Okay, now if you see, this character says that to make me smaller, you need something lesser than D. Okay, so basically it says that you can either use A, either use B, and either use C. If you ever use any of these 3 values, I'll definitely be smaller. Okay, so this is 3. But it tells us that I can never guarantee you what happens if you use D here, because this D is actually equal to this. Okay, so what we do is, we now generate another string. Okay, so basically what we do is, we know that we have fixed this value, we have also fixed this value now, and we see that we cannot fix any further values because the next values are actually similar to these values only. So if you see, if you fix this C and this C, D, so if we have C and D in the starting, then the third character will be C only. And if you see, this CDC is actually greater than CDB. That means we cannot have this as an answer. So if you see, we had 4 options from this place, 4 options from this place, and 3 options from this place. Therefore, the answer for this is actually going to be 4 plus 4 plus 3, which is actually 11. Okay, let's look at another test case to get a better understanding of this. Okay, let's look at the test case given in the input. Now we have A, B, C, D, and D. It says that let's see if there is any. Okay, so basically we are actually going to start from this index. Okay, now it tells us that let's see if there is anything smaller than this A. We know that A is the very first character, therefore there is nothing smaller than A. Okay, then let's move on to the next index. Now we have already fixed this A, so basically in every answer this A is fixed. Now let's move on to this B. We see that there is one value which is in particularly smaller than B, which is actually A. Now if this is A, that means a last character is also A. If this is A, then a second last character is also A. Now this says that since because of this A, I am already smaller than this string, you can use anything in the middle part. Okay, now by anything, what is that anything? So basically we know that K here is 4, sorry, K here is 5. Okay, that means we can use A, B, C, D or E here, which is nothing but K. Okay, so we see that due to this particular index, we can have 5 palindromic substrings, which is actually 5. Okay, then it tells us that I am done with A. Now let's go to B. So it says that since the first character is B, A, let's have the last also A. Then the second last character is B. Because this is B, the second character is B, the second last character is also going to be. Okay. Now we come on to the middle position. It, it says that we already have C in the middle. Therefore, every value which is smaller than C is a palindrome which is smaller than this particular string. So we have A and B. Therefore, two more cases. Now it says, let's fix this value as well. Okay, so if we fix the middlemost value, we get A, B, C, B, A. Now it tells us is that just compare this string and see if this string is smaller than this string. We see that this string is smaller, therefore we add +1 as well. If you count all the cases, we had 5 cases from here, 2 cases from here, and 1 case from here. And the sum of these is actually 8, which is the answer. So essentially, what we need to do is, okay, let me just generalize this now. Okay, so what we need to do is, let's say this was a complete string. And let's say this was the middle part of this. Okay, now I know if I fix anything here, this will also get fixed. If I fix anything on the second value, second last value will be fixed. Okay, what I do here is, so basically we have S1 here. I try to put every value which is smaller than S1 here. Okay, and for every value, I know that, okay, let's say that we had B here. Okay, if there was B, I know that I can place A here. Okay, now when I can place here in every other value, okay, so last value is also A. Let's say that there were 4 more indexes, 3 more indexes here, and okay, so let's say if n was 8, and let's have any random k. If the very first value was B, then we can actually take A in the first index. Now we know that there are k options for this particular index, k options for this particular index, and k options for this particular index. And same will be reflected on this side as well. So if we see the total number of palindromic strings that we can make if we fix A on the very first character are k cube. Because there were 3 places and every place had k options. Okay, now it says that what happens if I try B here? It says that B is already here. Okay, that means we need to move on to the next index. So after this first index, we move on to the second index. Let's say there was C here. Then it tells us is that we can either have A here or we can have B here. Okay, so let me write this. So this is B. The last character is already fixed as B, and this also B. It says that if I put A here, then again A will be here. If I put B here, then again B will be here. Now this A tells us is that I have 2 more characters remaining from the center. Since I have 2 more characters remaining, there are k options into k options. And this B also says that I also have k into k options. So basically this will give me k square more palindromes, and this will also give me k square more palindromes. And similarly, we will move on to the next index as well. We will say that, let's say if this is any S3, then we'll take every character which is smaller than S3. Okay, every character which is smaller than S3, we will take that particular count and multiply it k times the number of values that are left from the middle. Okay, and like we have to handle this for both even and odd cases. Okay, one particular thing that we need to handle in the end is that when we reach at the center, so let's say like if there was some S4, we tried everything which was smaller than S4. After that, the string will become BC. This is S3, let's say whatever there was, and we know that this will be B, this will be C, this will be S4, and this will be S3. So this is the final string that we will have. We need to check this string with the original string that we were given and see if this is smaller. If this is smaller, then we need to add +1 to the answer as well. Okay, because as we saw in this ABCDD, in the end we had to see the string ABCBA as well. Okay, and that is how we are going to do it. So let me just show you the code. Maybe it will become more clear with the code. Okay, let me just bring my code. Okay, Okay, let me open some editor. Okay, cool. Okay, so this is the code. Let me just explain it thoroughly. Okay, let me read the comments. Hemant says, is it given that string given is in lexicographical order? No, it is given that the results need to be lexicographically smaller. Okay, I assume so. Seeing test cases problem was difficult. Uh, it is not that difficult. Yeah, it is obviously difficult for the very first problem. I think they should have taken the second problem as the first problem and this problem as the second problem, maybe. But anyways, let me just explain the complete solution. Okay. So basically, what I'm doing is, if you see, I just scan n and k and the string. After that, I first find out the middle index of the middle value. So basically, if this is the complete string, let's say for even and odd. Okay. Let's say for even if the string was like of length 10. Okay. Or let's say if it was of 4. What I do is I say that my n now will become 4 plus 1 by 2, which is nothing but 2. And if you see, if you like index the string also of length 4, you see that this 2 is actually, okay, just a second, till 3 I have. This 2 is actually just 1 ahead of the center. Okay. And if we have odd values, so let's say we have 5, then I say my n is actually 5 plus 1 by 2, which is 3. And if you actually see, this is 0, 1, 2, 3, and 4, we can see that this 3 is just 1 ahead of center. This is the center and this is 1 ahead of it. Okay, and similarly here as well. So that is how I am finding the n first. Okay, so basically my n actually signifies the center here. Okay, then what I'm doing is, I know that if this is the complete string, this is the center for every value. So basically if you fix any value here, let's say we fixed a here, and let's say there were any like x indexes here, then we need to have the value of k to the power x. Then in the next iteration, we might need k to the power x minus 1. In the next iteration, we might need k to the power x minus 2. Okay, so what I'm code not visible. Okay, just a second. I'm really sorry for that. I think I. Okay, I think it's visible to you now. Okay, there was some issue. Okay, cool. Okay, I think it's visible to you now. Okay, cool. So basically, we will be needing. Okay, so basically, what I explained was. Okay, let me just explain that again. Okay, what I'm doing with n. So basically, let's say for let's consider an even case and an odd case. For even, let's say n is 4. For odd, let's say n is 5. So if n is 4, we have 0, 1, 2, 3. This is the string. Okay, I'm having it 0 indexed. Okay. Now, if I make my n as n plus 1 by 2, this is nothing but 4 plus 1 by 2, which actually comes down to 2. Okay, so this 2 is actually here, which is just 1 ahead of. This is the center, and this 2 is just 1 ahead of the center. Okay, and similarly for odd as well, I am making my n as n plus 1 by 2, which is nothing but 5 plus 1 by 2, which is 3. And if we see, when we have 0, 1, 2, 3, and 4, for 0 based indexing for an odd length string, this 3 is here, which is just 1 ahead of my center. Okay, so that is how, so basically this n right here is telling me my center. Okay, so after finding the center, what I do is, I know that if this is my complete string, this is the center. Whenever I fix any value for the very first character, let's say there were x more indexes, I need to 5 k to the power x. Okay, when I fix this value, I know that the total number of palindromes are going to be k to the power x, because for every index we have k operations, k possible values. So this is k to the power x. In the next iteration, when I fix this index, I'll have k to the power x minus 1 options. And similarly, in the next iteration, I'll have k to the power x minus 2. So what I'm doing is, I'm actually running a for loop from 1 to end, and I'm finding the power of k mod uh, with mod. Okay, so that I do not have to calculate this again and again. Okay, then okay, then what I do is, I actually start from 0 till n. Now remember, this n is actually the center. Okay, 1 ahead of the center. So basically when I do I equals to 0, I less than n, I'm moving till the center only. Okay, Now what I do is I see whatever my value here is. So basically if this is S1, I find out Si minus A. Basically that this is the count of all the values which I can place here. So if this was C, I know that C minus A is 2. That is because A and B are possible. Okay, if this was E, I know that I can just see E minus A, which is nothing but 4. That means I can place A, B, C and D. So basically in temp, I am storing this count. That is the number of possible characters I can place at this particular index. Then I know for every placed character, the possible palindromes will be k to the power x. So that is exactly what I'm doing. I'm finding the value of k to the power. So basically, if this is my n, this is my index right now. The values here, the count of values here is actually n minus I minus 1. Okay. Okay. So basically, temp becomes temp into power k. And then I just find the mod. And then I add this to the answer. Okay. And then I again find the mod of answer. So basically, for every index, I'm finding this, I'm adding this to the answer. Now one thing. So basically when I'm done constructing half of the string, I know my rest half is also constructed. Now I just need to check, maybe this complete string constructor in the end is also smaller. To do that, I just, okay, the very first thing I do is I have constructed this half string. I replace the rest of the half of the values in accordance to this string. So basically this value goes to here, this value goes to here, and similarly this value goes to here. Okay, so my x is changed. I have the complete string in x. I just see if this x is smaller than s. If it is, I just increment my answer and then I find the mod and then I print the values. Okay, so this is the complete logic of problem 1. Okay, Hemant say, Ayush says that 1 is solved. I don't understand what you mean by that, Ayush. Hemant says, I tried the same logic but couldn't code. Okay, Hemant, I think now you know how to code it. Make sure you are able to do this next time. Hiten says, sir, hats off to you for observing most of the content. They are so helpful. Helps us to think out of the question also. Thank you, Hiten. Thank you for the kind words. Sayandeep says ID. The name of this ID is CP editor. Okay, so you can just Google like, or what you can do is, okay, one more thing. So everyone, I also have a Discord channel, which is, okay, I forgot the URL. Just a second. Let me tell you the URL of that. It's bit.ly slash Naman Bansal 013. Naman, okay. Naman Bansal 013. Okay, so you can just write this in your browser and join the Discord channel. Okay, and you can ask all your doubts there as well if you want. And I also post my every schedule and when my like streams are gonna be. So you can just look at that and see. I also have a blog posted there on how to install this editor. Okay, so you can just look at the blog in that particular channel also. Okay, cool. I hope problem A is clear to everyone now. If yes, we can move ahead to the next problem. Can I have a confirmation or something from people if they're able to understand the very first problem? Okay. Okay, cool. Let's move ahead to the next problem, which is, where do we have? Alien generator. Okay, cool. Okay. Okay, so the next problem is, okay, let me just see if this is visible to everyone. Yeah, okay, cool. Astronauts have landed on a new planet, Kickstart, okay, whatever that is. They have discovered a machine on the planet, a generator that creates gold bars. The generator works as follows. On the first day, an astronaut inputs a positive integer k into the generator. The generator will produce k gold bars that day. The next day, it will produce k plus 1. The following day, k plus 2, and so on. So basically, on the first day, it is producing k bars. On the next day, it is producing k plus 1 bars. On the next day, it is placing k plus 2 bar, and so on. Okay. Formally, on day I, the generator will produce k plus I minus 1, which is right. So basically, for ith day, we'll have k plus I minus 1 bars. However, the astronauts also know that there is a limitation to the generator. Okay. If on any day the generator would end up producing more than g gold bars in total across all the days, then it would break. So basically, when this value reaches k, oh sorry, when this value reaches g, the machine breaks. Okay. Okay, till it will break down on that day and will produce 0 gold bars on that day and thereafter. The astronauts would like to avoid this, so they want to produce exactly k gold bars. Okay, so basically what they want is we have k bars in the first day, and the second day we have k plus 1 bar, in the next day we have k plus 2 bars, and so on till k plus I minus 1, such that this sum is actually equal to g. Okay. Then they've given us an example. So if k equals to 2, g equals to 8, on day 1 the generator would produce 2 bars, that is right. On day 2 we'll have 3 bars, on day so okay, so basically on day 1 we have 2 bars, on day 2 we have 3 bars. Okay, the sum of this is 5. Now on the next day we know that we'll produce 4 bars and the sum will become 9, which is actually greater than 8, and the machine would break. So this is not the best way. Okay, all right, cool. So basically, what we need to do is formally for a given k, for a given g, astronauts would like to know how many possible values of k on day 1 would eventually produce exactly g gold bars. Okay, so basically, what they want us to do is, okay, let's first have an example. Okay, let's look at one example. So if we have 10 as g, okay, if g is 10, then there are two cases. One is 1 plus 2 plus 3 plus 4. So basically on day 1 we have 1 bar, on day 2 we have 2 bars, and so on. Or the other option is we can just have 10 bars on one day. Similarly, if a J is 125, we have 4 options. Let's look at the 4 options. I myself do not know them. For 125 we have 4 options and they haven't given us. Okay, whatever these four options be. Okay, there are 4 options. Okay, so basically, okay, let's skip this. Okay, so if you see, when we are given a G, the very first answer can be that we can just have G bars on day 1. Okay, now, okay, so this is day 1 and we can have G bars. Okay, now let's say that on on the first day we had X bars and on the next day we had X plus 1 bar, such that the sum of this, which is 2x plus 1, is equals to G. Okay, then let's say that, so this is x1, let's say this is x1, so 2x1 plus 1. Okay, let's say that there was one consecutive way such that x2 plus 1 plus x2 plus 2. So basically on day 1 we had x2 bars, on day 2 we had x2 plus 1 bar, and on day 3 we had x2 plus 2 bars. Okay, the sum of this is actually 3x2 plus 3. Let's say this was equal to G, or not G, just we can just check if this is equal to G. If this is, then this is the answer, and similarly for this as well. Okay. Then let's say that we had another case which was x3 plus 1 plus x3 plus 2 plus x3 plus 3. Okay, these are 4 days. Okay, so basically we are trying out for 4 days now. The sum of this is actually 4x3 plus 1 plus 2 plus 3, which is 6. We can check if there is any x3 such that this value is equal to G. If there is any x3, that means we can add 1 to the answer. Okay, and similarly, so if you see, the next value will be 5x4 plus 10. Now, let's see something. So basically, let's say this was x0, okay, and x0 should be equal to G. Okay, if you see, we are doing nothing but, let's say if we had G, then we're just subtracting 1. For this particular case, we're just subtracting 1 from G. So basically, if 2x plus 1 should be equal to G, that means 2x should be equal to G plus 1. Okay, that means G plus 1 should be divisible by 2, right? Because if it is divisible by 2, then only we can have a value of x. Okay, similarly, if you see, for the next case, for 3x plus 3, okay, I'll just move my image so that you can see that. Okay, so if we have 3x plus 3, we can just check. So if this is equal to G, that means 3x should be equal to G minus 3. That means G minus 3 should be divisible by 3. Okay, and similarly, if you see, in the next case we'll get G minus 6 should be divisible by 3. sorry, divisible by 4. And in the next case, this 6 will become 10. In the next case, this 10 will become 15, and so on. Okay. Now, till when do we have to do it? So basically, if we just run a brute force, so this is not brute force actually. So if we just like first subtract 1, then we subtract 3, then we subtract 6, then we subtract 10, then we subtract 15, then we subtract 21. Similarly, if we subtract this and then just try to divide this by 2, here we have to divide it by 3, here we have to divide it by 4, here we have to divide it by 5, I think 5 only. Yes, 5. Okay. Here we have to divide it by 6, and here we have to divide it by 7, and so on. Okay. If we keep on going it till the end and count all the values which are possible, then we'll get a complete answer. I hope this is clear. Okay. Okay, cool. So I hope this is clear. Now, how to do this? So we know the agenda that what we need to do. Now, how to do it? Like, because we are given that this g is actually somewhat in the range of 10 to the power. This g is less than equal to 10 to the power 12, which is pretty big. Okay. Now, if you see, this is nothing but, let's say if this is n, this is nothing but n into n minus 1 by 2, which is 7 into 6 by 2, which is 7 into 3 by 2. Oh, sorry, 7 into 3, which is 21. Okay, cool. I think my marker is dying. Okay, cool. So this is 21. Okay. So if you see, this is nothing. So for n in the range of 10 to the power 6, this value will go into the range of 10 to the power 12. That means we know that we are actually dividing, like subtracting this value. So g minus n of n minus 1 by 2. This value, to keep this value greater than equal to 0, n should be less than 10 to the power 6. And since 10 to the power 6 is small, we can just run a loop from 1 till 10 to the power 6. Find all these sums for every like I. So for every I, we find the sum. Then we first, so basically what we do is actually for every, okay, let me just write the code. Okay, although I wrote a little different one, let me write a little basic one. Okay, I need a marker. Okay, so basically for I equals to 1, I less than equal to 10 to the power 6, okay, I plus plus, what we need to do is, we need to find the value of I into I minus 1 by 2. We need to subtract this by n, okay, sorry, this is g. We need to subtract this by g and then see if this is divisible by I. If this is divisible, if this is, then we add. If this is not, then we do nothing. Okay, we add this plus 1 into the answer. Okay, and then in the end we can just print the answer. So as you can see, the total complexity of this approach will be O of 10 to the power 6. Okay, so this is a fairly easier way. I did something similar in this lines only. Let me show that code as well. Okay, so if you, as you can see, so basically what okay, I need to copy paste my other answer. Just a second, let me show the other answer as well. Okay, okay, so this is what I did. I actually ran a while loop. Okay, so if you see, this is essentially the same thing only. What I'm doing is, so basically this is 1. So for I is 2. Then when I is 3, we are actually adding 2 plus 1. So basically this is 1 plus 2, which is 3. Then we are doing 3 plus 3, which is 6. Then we are doing 6 plus 4, actually, which is 10. We are doing 10 plus 5, which is 15. We are doing 15 plus 6, which is 21, and so on. Okay, so I took advantage of that case and I kept on subtracting that from n, and then I just tried to divide it by n, and I've incremented k here only. So you can also write this. I think this is easier to understand. This is just another variation of the same code. Okay, so this is all you have to do, and I hope this is clear. Can I have a confirmation from people in the chat if it is clear to everyone? Okay, I hope it is. This was, I would say, a little easier than the previous problem. Okay. Okay, if yes, you can just like the video and get to know that you're enjoying this video and like able to understand it. Okay, and you can join the Discord server as well. in that server you can like ask me questions or anything. I have some people also there, so if you have any questions you can just post them there and I'll be happy to answer them. Okay, and you can also get to know about my schedule as well. Okay, cool. I hope this is clear to everyone. We are done with both the problems. And also one more thing, one last thing actually. Let me just open my OBS. Okay. Okay. Also, we have on Code Chef also we have cook off starting at 9:30 I think. Cook off. Yeah, it's starting at 9:30. So make sure you give that as well. It is ending at 12. So I have a stream planned at 12:30. Okay, which is like 30 minutes after the contest tonight. Okay, so make sure you come to the stream as well if you have any issues and any problems. I'll try to solve all the depth 3 problems in the stream. But yeah, let's see how much time we have in that stream. Okay. Cool. So make sure you participate. At least participate. Even if you don't come to the stream, just participate. It's a very good practice to participate in all the problems. And coaching contests are really nice. Okay. Okay. Cool. Dhananjay says why k cannot be zero. Why k cannot be zero? For which case are you like? For which problem are you saying this k? I don't understand. Like, is this problem smaller strings or this one? Okay, we do not have a k here. We have k here only. K cannot be 0 because if we have 0, k is 0, then there is no character left and we cannot like make any string only. So having k equals to 0 makes no sense. Okay. Alright, cool. With this, I'll take my leave. I think we did a pretty good job in the two problems. I hope it's clear to everyone. If not, you can just like ask me in the server, Discord server anywhere. Okay, cool. I'll end the stream now. Thank you.